It's the AEMT lecture series. Welcome back. This will be video number 3 for chapter number 13. It'll probably be hopefully a much shorter video than the last two. We're going to talk about drug dosages. We're going to work some problems and and see what there is. So hope everybody's doing well. All right, so when we're talking about doing drug dosages, what we need to, some information we need. One, we need the desired dose. Okay, this is usually the amount ordered by the physician. The physician will tell you, 1 second, let me make this screen a little bit bigger. The physician will tell you to administer 4 milligrams of morphine. Okay, so the desired dose is going to be just that. So we'll just say 4 milligrams of morphine. All right. The next thing you want to do is you want to find out the concentration of the medication available. Okay. So here you have the dose, and this is also called the dose on hand. In this situation, we may have a total of 10 milligrams in 1 milliliter. Okay. And then the volume to be administered, we're going to figure that problem out. So the desired dose, again, will be 4 milligrams of morphine by the concentration on the drug on hand. Okay, and so the way you figure that out is you just take your 10 milligrams and you divide it by 1. Pretty simple there. And then to figure out the volume that you're going to administer, you take your 4 milligrams divided by 10. You're going to get 0.4. So you will administer 0.4 mLs. Bam. Okay, but we'll talk about it. We'll work some more problems. But these, at the minimum, you have to have these that much information. I'm also going to post a PDF on file that gets very deep. And I mean, it doesn't get too deep, but it goes deeper probably than what I'm doing. I got to see where everybody's at in order to know, how much help you might need. But it's definitely doable here. We can get anybody through this. All right. So you're ordered to administer 12.5 grams of dextrose to a hypoglycemic patient. You have a prefilled syringe containing 25 grams of D50. It's going to be in 50 mLs. How many milligrams of dextrose will you give? Okay, so this problem just wants to know how many milligrams, but we'll work it all the way through. So one, we have to have the desired dose. Hang on 1 second. I want to get a different color pen. Make it stand out a little bit. All right, so we want the desired dose. So in this case, 12.5 grams all right, of dextrose. Okay, so there's your desired dose. Concentration on hand. So it tells us that we have 25 grams. Okay, of D50. And it's in 50 mLs. Okay, so let's do the math on that real quick. So we have 25 divided by 50. Yeah, it's going to equal 0.5. So we have 0.5 grams per ml. And now we need to know because we need that would answer the question, wouldn't it? Let's see, 12.5 grams. Well, maybe it's just bad, but we're going to work it all the way through. Now we're going to need to know how much volume to administer. Okay, so in order to figure that out, we are going to take the desired dose. Oops. Okay, then divide that by the concentration on hand. Milligrams per ml. Sorry, this pen is not great. All right, so the desired dose here in this case will be 12.5 grams. D50. And we have 0.5 grams per milliliter. And let's do the math. Do the math. 12.5. Okay, and we're going to divide that by 0.5. And that's, whoops, that's going to equal 25 mLs. Okay, bam. It's not, I don't like to say it's not hard because it can be when you first start. But it's just following some steps. That's all there is. All there is to that, really. Let's see what the next one. All right. Your order to administer 70 milligrams of medication Y to a patient. Medication is prepared as followed. You have 100 milligrams of drug Y and 5 mils of saline. How many milliliters must you give to achieve the ordered dose? All right, again, let's go back. Desired dose equals 70 milligrams of Y. Okay. So let's see here. And then they also call this, I say concentration of drug on hand, but they call it also the actual, the total weight of the medication. I like to do like concentration of drug on hand. Okay. And so it says that we have 100 milligrams of this drug Y. Okay, it's going to be in 5 mils. So we do the math. Take your 100 and you divide by 5. And what do you know would be 20? So we're going to have 20 milligrams of Y per mil. Now we need to know how much volume to be administered. So we take the desired dose. By the concentration on hand. So our desired dose is 70 milligrams of Y. We have 20 milligrams of Y per mil. And let's do the math. Here's 70 by 20. 3.5 milliliters. 5 mLs of Y. So let's say, I forgot to mention this. Let's say it's 3.7. Or, you know, you could even do this. I mean, certain medications you can round. 3.8, 3.9, that sort of, you can round if you need to. All right, weight-based medication. So sometimes we have to convert the weight to be able to deal with the problem, right? A lot of times what they'll do is they'll say administer, they may say administer 3 milligrams per kilogram of Y. You know, whatever drug Y wants to be, right? And so look, the easiest way to do this is just take the patient's weight in pounds and divide it by 2.2. Okay, that's what you know, that's the first thing you want to do. Go ahead and convert the weight. And so let's say let's say you have an 80 kilogram patient. And you divide that by 2.2, that's going to give you 36.3 kilograms. So let me just, I said 3 milligrams per kilogram, and what I say, 80 kilogram body or patient weight. Let's change it. Let's start over. Let's make it like 180 pounds. All right, so we're going to take 180. And we're going to divide that by 2.2. All right, that's going to give us 81.8 kilograms. Okay, so let me put up here what I did. Take 180, now divided by 2.2, and that gave me 81.8 kilograms. I need to put pounds here too. Okay, so you have 81.8 kilograms now. And so now all you got to do is this. So we need to give 3 milligrams per kilogram. All right, so what we can do is go ahead and round this to 82. So we can say 82 kilograms multiplied by 3 milligrams. So I'm going to do the math real quick. 82 multiplied by, I'll make that an X, so multiplied by 3 milligrams. That'll give you 246 milligrams. Okay, so now we have our desired dose. Our desired dose now will be 246 milligrams of Y. Then it's brought back to the same formula that we had earlier. Determine the concentration of drug on hand. Okay, so let's say let's say we have 10. Oh, that's not gonna work. Let's say we have let me erase that. Let's say we have 500 milligrams. Let me come down here real quick because we already done 2. We're going to say we have 500 milligrams in, what do you want? Maybe 20 milliliters saline. Okay, so we have 500 milligrams of drug Y and 20 milliliters of saline. All right, so we need to determine that concentration. Not a problem. Bust out the calculator, do the math. 500, 20, it's going to give us 25 milligrams per milliliter of Y. Okay, and now we need to determine how much volume to be administered. Not a problem. Desired dose is 246 milligrams. Our concentration on hand is 25 milligrams per milliliter. And we're going to do the math. 246 divided by 25. We're going to give 9.84 milliliters. Or we'll say 9.8 mils. Bam. All right, let me erase all that stuff. So we'll do another problem here. This. All right, here we go. So you're ordered to give you are ordered to give 0.1 milligrams of Narcan to your 40-pound pediatric patient. You have a prefilled syringe of the medications containing 100 milligrams and 10 milliliters. How many milligrams will you give the patient? How much volume will you give the patient to achieve the required dose? All right, so what do we have here? So we have 0.1 milligrams per kilogram, okay, of Narcan. All right, we have a 40-pound patient. What do we have to do here? We got to convert this to kilograms. How do we do it? We're going to take 40 pounds and we're going to divide by 2.2. Okay, so let's do that. Let's take our 40 pounds and divide by 2.2. That'll give us 18.1 kilograms. Okay, so that's our patient's weight. Now, up here we have the dosage, 0.1 milligrams per kilogram of Narcan. So let's do the math on that real quick. We're going to have 0.1 milligrams Narcan, and we're going to multiply that by 18.1 kilograms. All right, let's do the math. 0.1 multiplied by 18.1. That'll give us 1.81 milligrams per kilo, or 1.81 milligrams. All right, so we've done that. So now, what's our desired dose? So our desired dose is going to be 1.81 milligrams Narcan. Okay. And now we need the concentration of drug on hand, don't we? All right, so it tells us that what? Prefilled syringe of medication containing 100 milligrams and 10 mils. So we're going to take 100 milligrams, about 10 milliliters. Let's do the math. You wouldn't know it would be 10. And yeah, I don't need a calculator to do that, but at the same time, sometimes I start thinking too fast and I get ahead and I do make mistakes. So we have 10 milligrams per ml. All right. Volume. We need to know how much volume to give. So how are we going to do that? We're going to take the desired dose, which is 1.81 milligrams Narcan. We're going to divide that by the concentration on hand. That, which is 10 milligrams per ml. So let's do the math real quick. 1.81. So we're going to give 0.181. 0.181. All right, and so that's, you know, so when you're looking at, we'll show you some of those tuberculin syringes. That's what you'd want to give this with, a smaller syringe, so that you can give not quite 0.2. All right. Let's look at this one. We got a 4-year-old boy who's in asystole, requires 0.01 milligrams per kilogram of epinephrine. You have prefilled syringe of epi containing 1 milligram and 10 mils. All mothers tell you the weight is 35 pounds. So let's see here. What's important? Well, this is important right here. This is important, 1 milligram and 10 mLs. Child's weight is 35 pounds. Okay. So we know that we're given a weight-based drug, so let's do the math for the weight. Convert pounds to kilograms. All right, so 35 pounds. And we'll divide that by 2.2. See what we get. It's going to give us 15.9 kilograms. All right, we know we need to give 0.01 milligrams per kilogram. So we're going to finish up the desired dose here. So we're going to take 15.9 kilograms, and we're going to multiply that by 0.01 milligrams epi. Let's do the math. 15.9 multiplied by 0.01. It's going to give us 0.159. Okay. Looks good, looks good. Okay, milligrams. Epi. So that's our new desired dose right here. Okay. 0.159 milligrams of epi. All right, so let's do concentration on hand. All right, and so it tells us that we have 1 milligram in 10 mLs. Okay, let's figure out our concentration. 1 milligram divided by 10. It's going to give us 0.1 milligrams per milliliter. Okay. All right, and we need to know volume now. How much volume to administer? Okay, and volume is going to be our desired dose again, which is going to be 0.159 milligrams epi. And we're going to divide that by the concentration on hand, which is 0.1 milligrams per mil. Let's do the math. 0.159 divided by 0.1. All right, and we're going to give 1.5 milliliters of epi. Bam. There we go. All right, guys. I mean, that's pretty much it. I'm going to post this, not PowerPoint, PDF that I have on drug dosages. Go through it, work some problems. We'll work some problems in the classroom as well to make sure everybody understands how to do this. And then we'll be golden. So you guys have a great day. This will be the last video for this series, for this chapter anyway. And I look forward to talking to you guys very soon. Take care.